Okay, so we've established that if there's an answer where the cosine is positive 0.6435 radians, there's also going to be an answer down here because cosine is positive wherever the x is positive. So here and here. If we're talking about positive angles, this one here, Liam, stop.
I'm sorry.
Every time we add a full circle to this angle, we determine another angle that's in the same place and has the same cosine. It's really tricky to like mix the idea of a decimal with these angles in terms of pi, but this is what we're doing. We have this angle here, and every time we add a full circle to it, we get another answer. So sometimes in a pre-calc class, they might ask you for the general solution, which is a solution that tells you all of the angles. There's an infinite number of answers for this because you can keep going around the circle an infinite number of times. We don't want infinite answers, but this is what's called a general solution here. So it takes the first angle from the unit circle and it adds 2 pi to it. And then it takes this negative answer and it also adds 2 pi to it as many times as we need. So these two answers are from here. And if I add 2 pi to each of these answers, I'm still going to be on the interval from negative 2 pi to 2 pi. So let's see, this one here, if I add 2 pi to this one, I get this one. This one is when I start here and I subtract 2 pi, so I'm going backwards. So there's 2 places on the unit circle, but they determine 4 different answers because my interval is going on the circle the positive direction and also the negative direction. These are the same exact notes that are available in Schoology, so if you need more time to process that, they'll be there for you. Does anybody have a question before I move on? The next one should go quicker because you guys did this problem on the boards. We're good? Okay. I'm going to move on, but feel free to open that in Schoology if you need more. Okay, number 6. To solve the equation, we had to first get the signs to one side, so you multiplied both sides by sine x. So if you multiply by sine x, that will cancel this one out and make this one sine squared x. Now notice where the squared goes. Today on the whiteboards, I wasn't being picky about it, but it doesn't go on the x, and that would lose you a point on a test. It's the sine that's squared, not the x that's squared. Then you divide by 2, you get sine squared x equals 1/2. And when you square root that 1/2, remember the plus or minus. So a lot of you had a number over here that was like 0.707. And it does get you to the right answer if you don't round too much. However, because this lesson's on the unit circle, you should be considering where on the unit circle you would be looking. And so the sine is root 2 over 2 at 45 degrees, 135 degrees, 225 degrees, and also at 315 degrees. All 4 places. And it said from 0 to 360 degrees, so that's how you know to answer in degrees. Okay, number 7 is up there. About half the groups got through number 7. If you didn't, it's okay. It's not a race. Now 7's tricky because it's related to the ideas from the unit circle, but that angle might not be on the unit circle because you can see that the radius is 5. So that's like not a unit circle value. So it can be confusing when you're talking about these unit circle ideas, but you're not on the unit circle. They tell you what quadrant you're in. When they tell you what quadrant you're in, you're always going to draw your picture by starting at the origin, going out into that quadrant, and then going perpendicular to the x-axis. Then the sine of this angle would be your opposite over your hypotenuse, and you'll solve for your missing side. It could be plus or minus 4, but because we're in the second quadrant, it's negative 4. And then your cosine and your tangent. So not everybody got that yet. I'm going to slide it up so people can preview the next one, but if you didn't get it, you should get that now. Always true. So there are some well-known trig identities. 3 of them are called the Pythagorean trig identities, and they come from the fact that They come from the Pythagorean theorem, really. I'm going to show you on the board, which won't show up real well on this video. But if you have a triangle, and I'll just put it in the first quadrant just so that it's easiest. You have a triangle. The adjacent side is your x value, and the opposite side is your y value. And then, of course, the hypotenuse is 1, right? So if I use the Pythagorean theorem, I could write x squared plus y squared equals 1. But on the unit circle, x is the cosine of theta, right? And y is the what? X is the cosine, y is the sine. Very good. So cos squared theta plus sine squared theta equals 1. And it's called a Pythagorean identity because it comes from the Pythagorean theorem. And so later in your math career, you may be asked to memorize a few identities, including this one, but not yet, okay? But this identity is useful in solving this problem because it's hard to solve an equation when you have two different trig functions in it, if you have sine and cosine in it. So in this case, since sine squared plus cos squared equals 1, we solve that for sine squared, so, and it's 1 minus cos squared. And then we substitute that into the one you were given and distribute. All right, so that was difficult in itself, and yet it's still difficult because now we're going to factor something that has, do we factor? Yeah. No, they didn't factor, they did quadratic formula. Okay, so they do quadratic formula on something that has a trig function in it. And then show you the rest. All right, so I'll tell you about the rest. So that's your A, your B, and your C for the quadratic formula. We're doing quadratic formula in Algebra 2 right now. And you'll substitute those numbers in to the quadratic formula. What you find is not what x equals, it's what cosine x equals. So after you do that step, you would do the inverse cosine of your answers from the quadratic formula, and then you would finally get answers. Sometimes when you solve a quadratic trig function, not both answers will have solutions. So you know how you're going to get two solutions. Cos x equals this, cos x equals that. If you get cos x equals 3, your calculator will say error because there is no angle that has a cosine of 3. Okay? But at least one of them should have a solution. So I am done talking about our first set of notes.